Okay, so for the remainder of this section, we're going to now go over how you handle an ellipse when it's not centered at the origin. So everything we've done so far was just x squared, y squared, so your center was just 0, 0. These are going to look a little different. Now this chart, it has a lot of information, okay? I'm not going to talk a whole bunch about what's going on in here, but the things I want you to notice is that those tops of the fractions here, they have like x minus h and y minus k involved. That's what tells us that my center is no longer going to be 0, 0. The h and the k are going to be my new center. We have seen h and k when we talked about graphing circles. And when you graph a circle, you always pull the opposite sign. So when we pull our center here, whatever the h and k numbers are, we're going to want to make sure that we do the same thing. We pull the opposite sign. So instead of pulling negatives for both of these, we'd actually be pulling positive numbers. Now, if it's a plus sign in between them, then make sure that you pull a negative, okay? Everything about how we graph the ellipse, like finding our a squared, our b squared, our c squared, all of that stays the same. So I'm not changing that overall process at all. What we are going to change, though, is just my center. So I'm going to kind of go over how I would handle this. This is not the only way that you could graph an ellipse, but this is a way that I feel is easiest and tends to be like the least complicated for students. So when I'm given an equation that I can tell is not centered at the origin because it's got these pieces on the inside of my parentheses there, I'm going to start by graphing the parent. So for right now, I'm going to just pretend like it is centered at 0, 0. And I'm going to handle it like we did yesterday when they were centered at 0, 0. So I'm going to look at this and I'm going to still do the same things. I'm going to identify my a squared and my b squared, figure out if it's a major vertical, major horizontal, be able to find all those numbers that I need and graph it. And right now we're just going to pretend for the moment that this would be centered at the origin. So if I look at this equation, and we're just pretending right now, here's my parent. I rewrote it down here just so I can kind of pretend what this would look like. Is this going to be a major vertical or a major horizontal? Why major horizontal this time? Yeah, the 9 down here. Oh, my highlighter doesn't want to work very well. I'll just circle it. This right here tells me what it's going to do. Since the larger numbers underneath the X, that means it's a major horizontal. I'm just going to abbreviate that over here now and say MH for major horizontal. That just tells me when I write my vertices and my foci that those numbers should come first. The Y's should be 0. It's going to be stretched along the X-axis. Okay, so that means that my a squared would be the 9. So a is just a 3. And then 4 would have to be my b squared, which means that b is just 2. So they have that kind of written out for us already. We do need to find our focus points here. So we need to figure out what our c squared is. So we're still doing a squared minus b squared. So 9 minus 4, what is that? 5. And then I got to square root that. What is the square root of 5? About 2 point what? 2? Okay, so for my vertices, that's going to come from my A, and then my foci are going to come from this C, and those are both going to be the X numbers first. So if you need to write them out, you can. What I can do here is I'm just pretending right now that it's centered at the origin. So this is my center. And I'm going to go left and right 3. This is a vertice, and this is a vertice. And then for my focus points, those are about 2.2. So I'm just going to estimate where I think those are at. And I'll just put a little F by them. Okay, and then my B we said was a 2. So from the center, we're going to go up and down 2. And like I said, we could call those co-vertices if you want to because they're on the other side of the ellipse. Okay, and then I'm just going to sketch that in. And now what I'm going to do is take care of my transformation. So I'm going to look to see what happened actually in my graph. So I'm done pretending like it's at the origin. I need to actually figure out where is it supposed to be. So I go back here to my equation and I look at these numbers in the parentheses. So I've got a +1 and I've got a -2. That's telling me where my new center is. That's also telling me what directions it went. Remember, I pull the opposite sign. So when it says +1, I'm actually going to pull a -1. And when it says -2, that means I'm going to pull a +2. So that's my center, -1, 2. If I start at 0, 0, that center that I was pretending it was, and I go to this one, I went left 1 and I went up 2. This is my new center point. Okay, I'm just going to zoom in on that. From my origin, I went left 1 and I went up 2. Okay, that means all of my other points are going to do the same thing. They're going to go left 1 and they're going to go up 2. So I'm going to now do that to my vertice points, to my foci points, and to the co-vertices. I'm going to move them all left 1, up 2. Ooh, that was not very good. So I'm just going to go over this one. I'm just going to highlight it here. This is the one that I really care about for right now. Okay, that's the new one. But then down below where they're asking me to fill in all this information, it's a lot easier for me now to just grab those points where my vertices are, my focus points, and then the endpoints of the minor. Those would be those co-vertices. Versus having to think about this all in my head of, okay, if my original point was here and I move it this way and then I move it this way and you're trying to think about all that in your head, it's maybe easier to grab these points now after the fact that we've graphed it. Like my vertices now are at -4, 2, and 2, 2. My focus points, now these ones again, we're going to have to think about the decimal because it started at 2.2. So it would be -3.2, 2, and then the other one would be 1.2, 2. Okay, and then those minor points would be at -1.4 and -1.0. And I'm just reading all of that from my graph. I think it's a lot easier to do it that way than to try to think about here's the original center or here's the original vertex. Now let's do the math by making it go this way and go up and all that. So it's easier, I think, to graph first and then label all those points. Okay, do we have any questions on how I did that? Start with your parent, then move it all. I think it makes it a lot easier. So I want you guys on the next page here, there's another one. Go ahead and see what you can do with it. Okay, so I rewrote this so it's just looking at my parent. Is this a major vertical or a major horizontal? Look for the largest denominator. So that'd be the 25, and it's underneath the y. So y would be your vertical axis. So it'd be a major vertical. So this tells me that. Which means 25 would have to be my a squared then. It's always the larger number. So what would just be a? 5. B squared then would have to be 9. So b is 3. To find c squared, we're going to take 25 minus 9, which is how much? And the square root of 16 is 4. So c actually comes out to be a nice number for this one. Okay, so now I'm going to graph this like it's centered at 0, 0. So this time you're going to go up and down 5 for your A. These would be your vertices. And then those foci are at 4 and negative 4. And then my B terms are at 3. So left and right, 3 from the center. Okay, that's the original ellipse, but now we need to think about what actually happened here. So looking at the numbers with those x and y back at the very beginning of my equation, what's my center? Good, 3. Yeah, 3, negative 4. That means that my center is going to move right 3, and it's going to go down 4. So all of my points should do that. So there's your new one. And then we can list out all the points. So now my vertices are at 3, 1, and 3, negative 9. Good. The foci? Oops, that should be a negative 9. Good. And then the minor endpoints? Very good. Okay. Questions on that? Okay, so we're going to end now with writing out the equation of an ellipse, just like yesterday. You guys did your graphing first, and then you had a couple problems where they gave you some information about the ellipse, and they wanted you to come up with the equation that it came from. That's what we're going to do now. But we're going to still have this, that it's not centered at the origin. Okay, so when it's centered at the origin, it's a little bit easier, I feel, to like figure out where the numbers should go and what your A and B should be. When it's not centered at the origin, we have to do a little bit more work. So one situation that you might run into is that they give you some points that would be on your major axis and your minor axis. We're going to use those to help us figure out what's my A and my B so that I can write my equation. It's saying that my major axis has points at 2, 2, and 8, 2, and then my minor axis has points at 5, 3, and 5, 1. Steps are to figure out what are the midpoints of those two axes so that we can figure out where the center is. And then we'll find the distance of those because that'll help us get our A and our B, and then we should be able to create our equation. So to find the center, we need to find the midpoint of the major and the minor axis. When you're finding midpoint, you're just adding the x's together and dividing by 2, and you're adding the y's together and dividing by 2. So for the major axis here, the x's are 2 and 8, so we're adding 2 plus 8, and we're cutting that in half. That's how they got the 5. And then 2 plus 2 divided by 2 is going to be 2 as well. It doesn't really matter which set you do that with. They just chose to use the major axis points when they did the midpoint. You would get the same answer, though, if you did it with the minor. Because if you did 5 plus 5 divided by 2, that's still 5. And 3 plus 1 divided by 2 is still 2. So it doesn't really matter which one you go with, but this is going to be your center point. So we'll have to think about that when we're writing our equation. That's going to go in with our x and our y. Now to figure out the a and the b, the major axis is going to help you find your a. So this is going to give you whatever your a is, and this is going to give you whatever your b is. Because that's just how it always works. The major axis always is associated with the a term because it's always the larger of the two denominators. To find how long it is, we use our distance formula. Now, it's been a while probably since you guys have used your distance formula. So I am going to write that out up here in case you don't know it. But it's a really big square root, and you do x2 minus x1 squared, and then y2 minus y1 squared. Those sub numbers, like they're really not a big deal as far as like how you plug things in. You're just putting in your x's and you're putting in your y's. You're subtracting and you're squaring it. You should always get a positive answer for distance. It should never be negative. Okay, you can't travel a distance that's negative. You can't measure things in a negative way, so distance is always positive. And so they're showing you down here how they did that for both the major and the minor axis. Now the top one is using the major axis points. So that's here where it says like 2 minus 8 squared. And then directly underneath that, they're doing the minor axis points. They're just plugging it into the distance formula and they're just chugging along. So when they did this for the major axis, they got the square root of 36, which is 6. And so that would be your part of your A. But that's like the full length of the major axis. Like the major axis is 6 units long completely from tip to tip of the vertices. If we want to know what just A is so we can write our equation, we need to know half of that. Because A would be from the center to one of the vertices. So half of 6 is 3. So your A is going to be 3. So A squared would be what? 9, because it would be 3 squared. And this is going to be your major axis. So maybe just write major underneath that. Then for the B, we do the same thing. They plugged it into the distance formula using the minor axis points this time. They got a 2. We have to cut that in half. So my B is just going to be a 1. So B squared would still just be 1 because 1 squared is just 1. And so that's going to be my minor. Now it comes to plugging things in. So over here, the major axis, how you can kind of tell if it goes underneath the x or the y is looking at the coordinates here. The major axis has 2, 2, and 8, 2. The y coordinate is unchanged. So then those x's are changing, which means it's going to be moving left and right from your center. So that would be telling you why it's going to be underneath the x squared. So the 9 is the larger one, so that's going to go underneath my x squared term. If you look at the minor axis, the same thing's happening here. We've got 5 and 5, but there's less distance that follows between 3 and 1. Like up on the major axis, there's 6 units between those points along the x-axis. On the minor, there's only 2 between them. So that's why we know it goes underneath the x. And then the smaller number 1 goes underneath the y. And then just think about what they did here with the center. They're reflecting that by doing minus 5 and minus 2. I said earlier that's one situation that you might run into because there's another potential way that they might give you this information. They might actually say in the problem, your major axis is blah, blah, blah. And then it's a little bit easier actually. So that's what we're going to do on this next one. This next one, and this is our last one here. They're saying that the major axis is vertical. If the major axis is vertical, that means it's going to be underneath your y. So I'm just going to write here, a squared will be under the y. Okay, so now let's keep seeing what they're giving me here. It says vertical with a length of 20. That's the whole distance. So how far is it just halfway? 10. You're going to take 20 divided by 2. That's going to be your a. So if a is 10, what's a squared? 100. Okay, so then the minor axis would be going underneath the x for this one because it's horizontal. Okay, so this tells you it's going to go underneath the x. Half of 10 is 5, and that's your b. So b squared is, square it. Take 5 squared. 25. And then they are giving me my center. 2, comma, negative 3. So when we write this out, we're going to do x, is it plus or minus 2? Minus. Squared. And then what number did we say is going to go underneath the x? The 25 will. Okay, and then we have plus y. Yeah, plus 3, because the center is a negative 3, so we got to switch its sign. And what number goes underneath that? 100, and it equals 1. That case is a little bit simpler because they're kind of spelling out a little bit more of that information. You don't have to do as much finding of things. Any questions? Okay.